We're looking at question 73 in the AP Statistics Midterm Review packet, and this is one I would focus on knowing how to do when it comes to a free response problem. And the reason why is there's some tiny details that could drop you from an E to a P or from a P to an I. So do pay attention to how you should complete this problem if it was not a multiple choice. We're being told in this problem that in a certain town, 60% of households have access to broadband internet, and we are told 30% have at least one high-definition television, and 20% have both. We're being asked to find the proportion of households that have neither broadband internet access nor a high-definition television. So in this case, I'm going to focus on how would I do this for a free response first. And really what I'm going to do is I'm going to have to define my variables. I'm going to say A represents the households with broadband internet and B represents the households with at least one HDTV. That is one thing you do need to focus on, is being able to define your variables. So if you're going to use them, you better define them. So I defined them, and now I'm going to kind of highlight which parts deal with which. And so first thing I'm being told is that I have probability of A, households with broadband internet, is 60%. Probability of B is 0.3, 30%, at least one HDTV. Now, right after that, it says 20% have both. Now, if they have both, that means we have the probability of A and B. So I really have three pieces of information given to me if I define my variables. I'm told households with broadband internet access. I am told at least one HDTV, and I'm told, hey, both. So if I'm doing this, there's a couple ways to go through this. You can either do a Venn diagram, or you can do a two-way table. I'm going to show both in this situation. And so let's start with the Venn diagram first. And so if I have a Venn diagram, I'm going to outline it like this. And if I have here, I have event A and I have event B. I'm trying to figure out what's going on. Now, when you have a Venn diagram, where you want to start is you want to start in the middle. You want to start at where they overlap, because where they overlap, that represents the probability of A and B. So that's where you should start. In this case, we're told 20% of households have both. And so I'm going to put down 0.2 here. Now, the reason why that's important is because if I want to find the probability of A, which I know as 0.6, that means this entire circle contains 0.6. Notice that 0.2 is already in that circle. So really what I need to do is I need to put a 0.4 here, because that whole A now contains 60%, 0.4 plus 0.2. So there's your probability of A. Now, if I want to find the probability of B, in that case, I have to keep in mind that B is focused on this entire area. And we're told 30% for that one. Well, I already have 0.2 inside that circle. So in that case, I'm going to need 0.1 here. And so that is the first part of the Venn diagram. What happens is people may stop. Do remember what the question is asking us. The question is asking us, we want to find the probability that they do not have. So that means complement, doesn't it? Probably that they do not have broadband internet access, and they do not have, again, complement, at least one HDTV. So I'm trying to find what's not in A, and also at the same time, not in B. Well, that'd be the outside. That'd be this part right here, not in A and not in B. Now, the whole thing in the Venn diagram contains 100%. If I were to add the 0.4, the 0.2, and the 0.1, I get 0.7, which means 30% do not have either. And so when you start the Venn diagram, where should you kind of focus with first is focus on where do they overlap, because that's going to allow you to start at what they have in common and build outwards from there. And so I believe that means my answer for this should be C, 30%. Now this is a Venn diagram. What if I wanted to focus doing a two-way table? And so that's what we're going to look at here. So you can see the answer. The Venn diagram is up on top. Now let's focus on a two-way table. And if I have a two-way table, here's what I'm going to kind of focus on. I'm told the totals. I am told probability of A, which means all the way down here, that probability is 60%. So I'm going to put 0.6 here. I'm told the probability of B, which is the total, so it goes all the way over there, is 30%. So I'm going to put 0.3 here. Now we can fill everything else in. I'm told that both, which means that they have A and B, that'd be this, it's where they intersect, A and B, that is going to be 20%, so that's 0.2. Now remember, the whole thing adds up to 1. I have everything I need because I can kind of fill in some information. I can fill in that this 0.3 and 0.7 add up to 1. 0.6 and 0.4 add up to 1. Notice the whole B column says 0.2 something adds up to 0.3, so that's going to be 0.1 here. And then I could say this is 0.4, but really what I'm looking for is this one right here. I'm looking for what's not in A and what's not in B. That's what I'm trying to find. A complement and B complement, the intersection of those. So again, notice I have the 30%, which is my answer here. So this is a good one because it shows you how to go through it, approaching it from the Venn diagram standpoint, which is important on where you start, and how to approach it using a two-way table. So hopefully this helped clarify question 73.